Does it have a timer?
It's on.
It's on. We're on. Let's go. All right. So I want to start proofs with all of you today, and then you get to practice the easy part of them tomorrow. So 1.7. Does it look okay, Brock?
Yeah.
Okay. Thank you. Proofs. And we're going to spend all week on this. Maximizing, again, our in-class time. Some of it will be out of class, but our goal is to maximize inside our class time. All right, so what is a proof? In its fancy terminology, a proof proves a conjecture true. So that's just using some fancy terminology from inductive reasoning, conjecture. Really, a conjecture is just a statement. How's the glare, Brock?
Not bad.
Okay, thank you. So just going to prove a statement true. That's its technical definition. A non-technical definition is a proof provides us with there's a beginning, a definite beginning, which in the proof writing world that's called the given. So a proof has a definite provided beginning, it's called the given. And it has a definite ending, which is called your proof statement. And the proof is what happens in the middle. How do you get from the beginning to the end? That's the big idea of a proof. It's the how. How to get from the beginning to the end. So when you're thinking about what it is we're doing, we are creating this how-to steps. I know what I start with. I know what I end with. It's how to get there. So if I give you the ingredients, these are the ingredients. You're making banana bread. You have to come up with exactly how much of each ingredient do you need to be able to bake this beautiful thing of bread. It's hard. That's why it's hard. Yeah, you know banana bread. You've got all the ingredients, but if you put in too much baking soda, you're going to end up with something that blows up in the oven. If you put in too much flour, it's going to be as hard as a rock. Okay, so it's hard because the how-to is the stuff that's the most important, most challenging to come up with. And could I make one recipe that takes me up here, and a different person makes a little slightly different recipe that goes this way? Yeah, it's all gray. Everybody could have their own recipe, their own proof, and still have the right answer. So that is why, Grace, it's hard, miserable. What were the phrases? Awesome. Pretty sure it was one of them too, right? All right, so this is what we're up against. Here's what it looks like. We're going to do something called a T-chart for every proof we ever write. A T-chart. So the proof, our how, will come in a T-chart form. This is called the statement section. And this is the reasons section. Every time you write a proof, you will write those words, and I will give you credit for setting it up correctly, actually. I really do appreciate it when people keep them somewhat organized so that I can grade a little easier. It's up to you if you draw the lines, but I do like the numbering system. Each proof will take a modified number of steps, or not modified, but a different number of steps. Typically anywhere between 3 to 5 is your average proof length. A lot of times in the beginning I'll tell you exactly how many you need just to get you started. So a lot of times I'll provide you with the number of steps that you need. So this is what our how will look like. are given. Every time you have a proof, it will state given. And in our case, I'm going to go ahead and say our given is -5 equals 3n plus 1. And I'm going to go ahead and say that our proof is n equals -2. This given is our first row of information. The reason is the given, the word given. And what I'm provided with is my statement. I'm going to start you out nice and easy with statements that are algebraic in form, so you'll be able to solve them fairly easily. But no matter what type of proof, geometric or algebraic, this given is row 1. That information that I gave you is row 1. Making the ending statement what we receive in our proof. So I just gave you the answer to the algebra problem. It's your job to tell me how to get there. You will never use the word prove in a proof. It's like using the word in its definition. You can't do that. Okay, so this is again every single proof you write has this setup. So if you can do this, that's at least some credit. That's a start. Our given is at the beginning, our proof is at the end, and our statements and reasons columns are ready to go. Statements are how you go from first step to second step to third step to fourth step. The statement side of this will be really easy. You're going to know how to do this already. What would you do in algebra if this was a problem in front of you? Subtract 1. So this statement side is going to become pretty easy to you. Not always, but today, tomorrow it should. The reason side is a little bit more challenging. The reasons that you will use come directly from the blue sheet that I just passed out to you. The reasons can come from 3 specific locations. They aren't just willy-nilly come up with a reason. They have to be provided to you. There are 3 places you can find reasons. Reasons come from definitions, they come from properties, and they come from postulates / theorems. So the only 3 possibilities for reasons are here: definitions, properties, and postulates / theorems. Properties and postulates / theorems are going to be provided to you, handed to you each chapter. Back in the day, the students had to memorize them, and it's not that long ago. When I used to teach at the, can't mention it, place, Waukee, they had to memorize their postulates and theorems. It's just the way it worked. Okay, but this is the day and age where that's a little it's just ridiculous because you can access all the information you want. These are handed to you. This is going to be something that we may add together as a group to your blue sheet if we need it. But definitions are the one thing that you don't have access to unless we decide as a class that we need a couple of definitions and then we'll add them to our sheet so we have them. So this is your job to come up with. This has to be something that you pull off the blue sheet. It's the main idea of a proof. Questions before we finish this off? All right, and you're going to have a lot of them, I'm sure, but hopefully this type of proof isn't one of them. So let's go ahead and take a look before we finish it at the properties on our blue sheet. You can see them in the dark. They're about, 2/3 of the way down the front side of the blue sheet. The properties that we'll use addition property, subtraction property, multiplication property, division property, all of equality. And then symmetric property of equality. Those are the ones that we'll pull from. Addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality are just add, subtract, multiply, and divide. So those are really simple. The one that's not as simple as the symmetric property, but it's not that complicated either. If A equals B, then B equals A. That's really fuzzy. Kind of like it's conditional in converse format. If A equals B, then B equals A is a symmetric property of equality. All right, and all of these properties fulfill step number 2 of the 3 ways I can do reasons. So it's fair game. So let's do this together. You said subtract 1. So if I subtract 1 from each side, I am left with -6 equals 3n. How did I get from step 1 to step 2? Subtraction. So I'm going to do subtraction, property of equality. POE is a lot faster. Feel free to use it. Subtraction, property of equality. Substitution and subtraction are very similar, so I would encourage you to put the minus sign. Keep it simple for me to grade, so you can get as many points as possible. What would I do next to solve for my variable?
5/3.
Good. So division, property of equality. And then I would stop if this was an Algebra 1 class, because I know the value is -2. But my proof is specific to n is first. N is equal to -2, not -2 equals to n. So what property allows me to go from 3 to 4? Yep, the symmetric. So this part is pretty commonplace by now in your math career, solving equations. This is the part that we're going to start to add in, and it won't feel too complicated day one. The process is the key. Questions for me on any of that? All right, so I have a couple of minutes. I'm going to set up with you exactly what I want you to